Paulo is located in São Paulo State and São Paulo City. It was founded in 1934. It has 300 undergraduate programs, 222 graduate programs, and more than 9,000 students. Internationally speaking, University of São Paulo nowadays, it's very well ranked internationally, so we are very proud on that. And the Polytechnic School, actually, it was funded before the university. It dates 1893. It has almost 5,000 undergraduate students and almost 1,500 graduate students. So in the civil engineering departments, it's where we are, under the transportation engineering department. And this is some pictures of our lab that you are all invited to visit. So going to the technical topic, all this pavement recycling issue, it's related to the environment. So everything starts from there. In Brazil and in many other countries, we have, this picture is very common in Brazil. So we have a lot of old roads that need to be maintained in some way. And one of the options is to remove part of this pavement and rebuild in a new way, or trying to reuse the materials that you have extracted from there, milled from there. So we start from this environmental issue. If we think on the benefits of recycling, and now I'm talking in recycling in general, use this material some way. I guess this is the key point. The main focus of the presentation is the cold recycling, but it depends a lot on the test site you are. The main point is try to reuse this material. So the main benefit is the environmental aspect of the recycling. You will use less energy, you will reduce the use of new materials, sometimes you reduce the transportation time, and you can put all that together in the environmental aspect. So what we want with all these benefits, we want to have, as much as we can, a uniform monolithic layer. Can be a base layer, can be a surface layer, depends on how you are dealing with the recycling. So we want this uniform layer. We want to have some mixing accuracy, and I'm not saying that all this is easy, but that's what we want. We can go nowadays we can go as deep as we want. You can remove only the surface layer, you can remove the surface plus the base layer, you can do what is easier for your project. And you can also use 100% of the material that you've removed. I think this is the key issue. What brings us to this whole recycling aspects? We have the wrap. This is a point. What do we do with this material? What are the options? How can we better reuse this material in a rehabilitation project or in a new construction? So wrap, it's gonna last. I guess Sylvia have mentioned some aspect of the variability of this wrap. It will be variable in somehow. First, because if you are in an urban area, this material will be put in a stockpile, but it comes from different places. And depending on the project of that places, you can have different asphalt binders, you can have different aggregate gradations. So it has to be in perspective of your new project, of your rehabilitation project. These two pictures is just to illustrate some points that we can consider in using this wrap, I guess this pictures from NCAT, this one here, it shows that the wrap is covered. It's not only because it's wrap. If you can cover the new aggregates, perfect, to protect this material from the rain. If it rains, it will get more moisture on it, and eventually it will take much more time to remove this water from this material during the reuse it. The second picture, it's from a plant that operates 100% wrap. And one important thing is if you want to use this material in a hot or warm new asphalt mixture, recycled asphalt mixture, you will most probably have to separate this material in different sizes to avoid the uncertainty of your gradation. So in Brazil, our main issue in using the wrap for the hot or warm mix recycling is the plants. Our plants in Brazil are really not prepared to operate higher wrap percentages. But this is not the case in US, this is not the case in Europe. You have a couple of plants that can already operate 100% wrap. So, this slide is just an illustration. We have asphalt mixtures of different types, from hot to cold. If you are in a project that it's easier to use this wrap in a hot mix asphalt, do it. In Brazil, I've picked this cold recycling technique for two reasons. The first one I've just mentioned, our plants are not really prepared to use a lot of amount of wrap in the hot and warm mixtures. And the second one is the cold recycling mixture, they are normally used as a base layer. So if you get a concessionary, for example, they are less scared to use this material because it's on the base and not on the surface. The third point that I could mention is in Brazil, we have normally very deep base layers and thin surface layers. So in using the wrap on the base layer, you can use a larger amount of material at the same project. So the question is, we always have to ask this to ourselves if you are dealing with a recycling project. How much should you remove from the pavement that is some sort degraded? And this question is very important because sometimes you mile, let's say, 3 centimeters or 4 centimeters of an HMA, and you end up with the remaining asphalt mixture still with a lot of cracks. This picture is from a real project. They had to do it very fast, so they decided just to mile, I guess it was 4 centimeters, and put a new asphalt mixtures on the same place. Of course, after a few months, we had a lot of reflective cracking in the situations. So when we are facing this type of problem, sometimes you have structural issues. And remove just the surface, maybe it's not enough. You have to go deep on your pavement. And that, the cold recycling is an option. The cold recycling we can do in 2 ways. You can do in place or you can do in plant. As everything in our lives has advantages and disadvantages. I would consider the main advantage of the in-place recycling, the time. You can go much faster on the job site. And the in-plant, you are much more sure of what is coming out of the plant. What is your mixture, how it's facing, and most probably you know much better how it's going to behave. But sometimes we don't have the time. So, talking about cold recycling, we have to start with the materials also. What is the composition of a cold recycling mixture? We have the aggregates, and in this type of mixture, you have a couple of options depending on how deep you went on your damaged pavement. You can have new aggregates, you can have the wrap, or you can have recycled aggregates from the base course, and this base course can be granular, can be cement treated. Everything can be put on a cold recycled mixture. Water, it can come in two ways. I'll go a little more in detail on that later. The asphalt binder, you can use it as an asphalt emulsion or as a foamed asphalt. We can talk about that too. And the hydraulic binders, that you can use cement or you can use hydrated lime. These are the most common materials that you will probably find in a cold recycled mixture. This is a very classic picture, and I guess the main question here is, what is a cold recycled mixture? Does it behave as an asphalt mixture, or does it behave as a granular material? I have in there some sort of hydraulic binder, I have some sort of bitumen. So how is the behavior of this material? And I guess this is the key point. We don't know. Or it's going to depend on the amount of each component you are putting on your project. I've marked here 3 options. The cement-based treated material, cement bitumen treated material, the bitumen stabilized material, and the cold. The asphalt binders, I'm not sure. I guess emulsion is something more common for most of the pavement engineers. Like you're gonna mix your asphalt binder with water, and this water is just to facilitate the transport and the mixing process. Eventually it will come out and you stay just with the binder. The foamed asphalt, I've put this a small video here just to illustrate what is the foaming process. How does it happen? What are the advantages of this process? So the foaming process is basically to increase the volume of this asphalt binder. In the process of foaming, you have your asphalt binder at, let's say, 170 or 180 degrees C, a normal temperature. You put this hot asphalt binder in contact with water and air. And in this process of mixing all of them, the asphalt binder will try to expand. And it can expand 15 to 20 times the initial volume. So why do I do this process? Why do I do this foaming process? If my asphalt binder has a eventual higher volume, it's going to be much easier to cover the aggregates, the new aggregates, the recycled aggregates, the wrap, the material that you are using in your project. So this is the idea. So the amount of water is very important at this point. This chart in yellow, we have 2 parameters here that it's normally used to design the mixture. The half time and the expansion ratio. This time is related to the real amount of time that you will have on your plant to mix all your materials. So as higher this number, is better. So I'll have more time to make the mixing process. The expansion ratio is related to how much I have increased the volume of the initial material. So as higher this number, is better for me. So we normally design the mixture facing these 2 parameters. Even if both are cold recycled mixture, we may not consider them similar if I'm using an asphalt emulsion or if I'm using a foamed asphalt. The binder is there. The total amount of binder may not be that different, But the way this binder is distributed into the mixture, it's gonna be very, very different. So in the emulsion process, what we normally have, it's a more uniform painting of the aggregates that is facilitated by the water. In the foaming process, the foamed asphalt stick together with the fine particles, and if you make a cross-section on a lab-prepared specimen, you see a couple of spots with black marks from the asphalt binder. So it's not uniformly distributed. Regarding the gradation of this type of mixture, because in the foaming process, you need these fine particles to get sticked with the foamed asphalt, you need more fines. So I've put in here two different gradations from the Asphalt Academy and the from Vertigen. And in both of them, if you are using an emulsion, you can have less fines on your aggregate gradation. And why this is so important? We never know how the wrap will come up. If you decide to use or decide to make your rehabilitation project with the base layer, let's say the base layer, with a cold recycled mixture, most probably you don't know in advance how it's going to be the gradation of this wrap. It's going to depend on the speed of the milling process. It's going to depend on the depth of milling. It's going to depend on the machine. If it's a new one and the beads are old, most probably the material will come up completely different. So the design of the mixture at a certain point will depend on the initiation of the process of wrap production. So if I have a wrap that is very coarse, there is not too much fine on that, eventually you have to add some fine new aggregates to compose this mix and make it into this gradation curve. So this picture here I like a lot. It's from Professor Kim Jenkins from Stellenbosch. He is running a lot of research on cold recycling, especially in the foaming process. We have a close contact to them. And in this picture, we see clearly the influence of the fine. Not too much for the emulsions, but a lot for the foamed. So if you decide to run your cold recycling with foamed asphalt, you have to take care of the gradation of your aggregates. This is just an illustration. That is, we used to call optimum amount of binder. And this amount is not that much. We are talking about 2%, 2.5 maximum. I guess the project I've seen with the highest amount of asphalt binder was 3%. So it's supposed to be a cheap mixture. You are using wrap, so you do not have the transportation cost. You are not using that much asphalt binder, so it might be an interesting solution. Then we have to think a little bit, what do we want from this mixture? Is this mixture stress dependent, like a granular material that we know is stress dependent? These plots, if you look, the first one, this first one is for foamed asphalt mixture, and this one is from asphalt emulsion mixture. Here are the compositions of both of them. If you wait the curing process, and we'll talk about that a little bit more, if you wait for the curing process, most probably these mixtures will not be so stress dependent. But during the curing process, they are. We know that already from our results, from other researchers' results too. So what is the curing process? Remember that I've mentioned we have water in our composition, and it's not only the water that foam the asphalt. It's like the water that you put for a granular material, for compaction. We need that to be able to compact that mix in the field. The water is in there. You put your mixture on the field, you compact it, and the water is still there. It takes some time, and can be a lot of time, I'm saying months, until this material stays the equilibrium regards the water amount. So the curing is very, very important. The other question is this material, since it has asphalt, and we know asphalt is a viscoelastic material that is time temperature dependent, is this material temperature and load frequency dependent? And the answer is yes. So we know in the beginning of the process it might be stress dependent. During its whole life it's going to be most probably time temperature dependent too. So we have here a combination of the behavior of a granular material with the behavior of a viscoelastic material. And how to address this curing process in the lab? Because we have to design the mixture. And I guess the wrong thing to do is try to correlate with the field. We can never know how the curing process will happen in the field, because it's going to depend on the thickness of your layer, it's going to depend on the temperature of your environment. So there are many issues related to this curing process. But we have to set something in a lab, otherwise we cannot design the mixture. I'm not guessing you are able to read this table, and you don't have to, but we've run like a literature review just about the curing process, and you can find pretty much everything regard to the time, regard to the temperature. So any research group do in a certain way. We don't have like a standard procedure that everybody is following, and this is an issue. So because of that, we know that the mix design cannot take forever. We cannot wait 1 month to have a mix design, so the job site stop at 1 month because we don't have the mix design. So we decided to make some trials to speed up this process. And in these plots, we see this is like the temperature we've tested, and this is the time we've run 1 day, 3 days, and 7 days. By the end of this study, we realized that we cannot go up to 100 degrees C. We most probably start in somehow degrading this material, changing this material with the heating process. So nowadays, if we are doing cold recycling with emulsion, we do at 6 degrees C for 3 days. After that time, we've seen, based on different mixtures, that we can reach this stable value in a faster way. The foaming process, we've run a couple of tests on that too. And what you see in this plot is two different types of curing. We call the first one the drying process. We just put the specimens in a controlled temperature, 25 degrees C, and wait for a certain amount of time. And we can clearly see the increase on the ITS. And then we thought, okay, but in the field, this water does not come out so fast because we have a surface layer on top of it. Let's try to run the same test, and we have, in that mixture, we had hydrated lime. Let's try to keep this temperature controlled, but the specimen into a plastic bag. And what we've seen is, if the water does not come out for some reason, your strength will not increase too. So the curing process will not happen. What we know so far is to have this strength and stiffness increasing with time, so to have the curing process really happening, we will need to have the water, some water, to be able to increase the stiffness because of the hydrations. On the other hand, we need the water to come out to have the stiffness from the curing process. So it's like two ways. How does it happen in the field? We are monitoring right now two different highways, two different pavements. I'll talk about these two job sites in a little bit. But the curing process is very, very important. It happens in the field really. In this chart, this is a very emblematic chart. We have here the pavement structure after rehabilitation. So we have these two layers of foamed asphalt recycled mixture and just 3 millimeters of cap graded. And we see here, it starts at 120, the maximum deflection, and it went down until 20 with time. This one was after a little more, or almost a year. How to design this pavement? We do not have time to go that much into the design, but there are many different options. And I've divided these many options in 3 blocks. The first one assumes that this mixture, this cold recycled mixture, will behave like asphalt mixture, and most probably the failure will be because of cracking, fatigue cracking. The second group, they see this material as like a granular material with high cohesion, so the problem or the issue would be permanent deformation. And we have a third group that have a combination of both, like the material will behave in 2 stages. I will show you just a few slides about the 2 projects I've mentioned. The first one is a highway. If anybody has been in São Paulo, if you leave the airport to the city, we'll pass through this test site. The pavement structure that was there, it was like a base course, 30 centimeters base course, and we had an HMA. Both layers were extremely cracked because they are old, like from the 50s. This structure is from the 50s. So the rehabilitation project was, let's remove, because they have tried miling and putting some new HMAs, and it didn't work, of course. The base layer was completely cracked. So at a certain point, okay, let's do it in a right way and remove both layers. So the rehabilitation project was 34 centimeters of BSM, bitumen stabilized material, RAP, plus at this job site, we had the foaming process with the RAP plus the recycled aggregate from the base, all mixed together. We had to do this at night because of the traffic. We had a window from 11 p.m. to 5 a.m. to do what we had to do. So it's like we could go just 100, 150, maximum 200 meters per night. It's not allowed by the contract to close any lane. This is a 5-lane highway. By contract, you are not allowed to close any lane during the day. And in there, we could also see a decrease in the deflection with time. At this one, after 3 years, almost 3 years. Some back calculation modulus, so if the deflection tends to decrease, the modulus of the materials tends to increase. We expected that. The other job site, we compared the foam with the asphalt emulsion. The composition, if you check the composition of both, you may ask, oh, why in just one you've put new aggregates? Because in the foamed process, I need the fines, and the RAP didn't give me the necessary amount of fines. So we've put on the mix number 2, that is the foamed one, we've put 30% of new crushed stone. Here are the deflections, and the deflections were low since the beginning. It decreased a little bit, but it was already low, not that high as the previous structure. Why? Because in this one, I have 12 centimeters of HMA instead of only 3, as I had in another one. Some back calculations, so we can see this increase in the modulus of the base layer. The curing process, it really happens. If you check the strain that is going on the bottom of your HMA layer, you see clearly that it will decrease with time, just because of the curing process. Here's some simulation considering everything elastic. It's important to consider. If you check the stresses and strain at the bottom of your HMA layer, you see that after 15 months, it's gonna decrease because of the curing process. We've run some triaxial too after curing, and we corroborate that if the material is completely cured, the stress state on them is not that much. We've seen that for both the emulsion and the foamed. We've run the dynamic modulus, and this is important for us too. The time temperature superposition principle that fits for the asphalt mixtures, it works for the cold recycling too. So we see they are different. Although the resilient modulus, they are very similar, if you change from elastic to viscoelastic, we will see clearly that they are considerably different. Here are some deformation tests, and these results kind of impressed us at the beginning, because even though the modulus, the dynamic modulus is different, we've run the flow number test, and the foamed asphalt performed much better than the asphalt emulsion. And these mixtures are the same that we've put on the field. In here we can see the influence of temperature, now considering them viscoelastic. So if my surface layer and my base layer are both viscoelastic, I may have to consider that in the project too, because the transfer of stresses and strain from one layer to the other will be different. Here's some speeds. I'll jump to this one. This is the final slide after my final considerations. And these two mixtures, they are in the field with two other structures. One, completely flexible. This one is gone already, by the way. After less than 2 years, we had 70% of the surface cracked. So the heavy traffic, the flexible structure didn't work there. So here we are looking for the stresses at the bottom of the HMA. If we compare the flexible structure with the semi-rigid structure, everything is okay. If I have a cement-treated base, my HMA will not be under tension. It's going to be in compression, the bottom part of the HMA. What happens with the base asphalt layer? It's really in the middle of both. Here after the curing process. So as my final consideration or closing remarks, the recycling benefits, we know this already. And somehow we just have to make the process in the labs and on the job site better, to have a more reliable mixture, to have a more reliable pavement by the end. We cannot neglect the curing process. We believe now that if you put this mixture in the field, the main issue at the beginning might be permanent deformation because the curing process didn't happen. So stiffness is very low. We still have water inside. After a year, if this water is not there anymore, if the curing process really happened, maybe you have to consider that this mixture may be under fatigue at a certain point. It's going to depend how is the stress distributions in this pavement. You have to account for REP variability. It happens a lot in Brazil. We can have REP anyway, with neat binder, with modified binder, with 19 millimeters asphalt mixture, with 9.5 millimeters asphalt. So you have to deal with that. So if your REP has a very high variability, maybe it's better to consider this design in a plant and not in the field. And this material, depending on the amount of binder, in binder I'm saying the hydraulic binder and the bitumen. Depending on the amount, this material can be stress dependent, time temperature dependent, all this together. These are the two structures I've shown of the two test sites. The first one, I have only 3 centimeters of HMA on the top of this mixture. And the cold recycle itself has just 1% of hydrated lime and 1.8% of binder. The second structure, it has 12 centimeters of HMA, 3% of binder, and 2% of cement. Both are cold recycled mixtures, but they are different. And most probably, the structural concept of these two structures too. So, how is the failure mechanisms on these both structures? That's what where our investigation is right now. We just cannot think that, okay, I know, I've run the tests in the lab, I know my mixture, if you don't put this in the structural perspective. The mixture does not work by itself. It works together with the whole structure, and we have to consider that. So I guess the main point that I want to make on this presentation is that when you are dealing with cold recycling, you have always to look of the mixture design and structural design together. You cannot do any one separate. Thank you so much. I want to invite you all to be in Brazil next year. We are going to have the International Society Asphalt Pavements Conference in Fortaleza. I'm living in São Paulo, but I'm from Fortaleza. I can assure you it's a very nice city to visit, and I hope to have you there by that time. Thank you.